Hello, let's continue our Sudoku adventure with Odd Repulse by GDC. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these lines in the grid. They're yellowish. I don't know what to name that color, but anyway, these lines are Nabner lines, which is Renban backwards. So they're kind of reverse Renban, but definitely pay attention to the rules here. So if a digit appears on a Nabner line, like a 2, then that digit and the digits consecutive with it do not appear elsewhere on the line. So we do not put another 2 on the line, but we also don't put a 1 or a 3 on the line. So for every digit that's on the line, itself and its consecutive digits, the digits that are consecutive with it, do not appear on the line. All right, we also have these yellow circles in the grid, and they indicate the number of odd digits that appear on the attached line, including itself. So what's a good example? If this was a 1, then these two would have to be even, like 2, 4, to have 1 on the line. If this was a 3, then these two need to be odd, like 1, 1, 3. Well, we can't repeat on the Nabner, but anyway, we could do this, for example, and we'd end up with 3 odds on the line. So this is the count of odds on the line, including itself. And then the blue squares indicate the number of even digits which appear on the line, including itself. So if this was, say, a 2, we could do, I don't know, 5 and 6. I don't know. I'm ignoring the Nabner for now because I think that's probably what the puzzle is. I don't want to give it away. And so at least for the counting, the even lots counting, there are 2 evens on this line. So that works. All right. And that's it. Those are the rules before I accidentally start solving the puzzle. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I think this line and this line and this line are probably where we want to start. I don't think it really matters which one we start with. Let's just think about this one since I'm here. So this line is 3 length, right? So there can only be 1, 2, or 3 odd digits on this line just by counting, right? In fact, we can put 1, 2, 3 there. We can put 1, 2, 3 there. I think we can do better than that. This is 1 or 2. This is 1 or 2. So one option is there's only 1 odd on this line, in which case both of these are even. So if this is 1, then both of these are even. And so we can't do 1. We can't include a 2 though. So we'd be 1 and then 4, 6, which seems reasonable. If this was a 2, then these both have to be odd, but the 2 removes the 1 and the 3. So there's only 1 odd left. So 2 just doesn't work. So this is going to be odd. If it was a 3, then this has to be 1, 5. So we can do the same thing here. It's because we can't repeat on Nabners. We don't care that this is in the same box and this isn't. So 1, 3 here, and then 1, 4, 5, 6 here. Now for the evens, if there's 1 even, then one of these 2 is even. I guess that's not... I don't see how this is as restricted. Let's look at these 2 cell lines. If there's 1 odd, well, this just can't be a 2. We can't have 2 odds, but then have this be even because it's a 2. So that's a 1. And here we could have 1 even or 2 evens. Both cause this to be an even. I'm going to clean this up in a second. I just want to think about this. So yeah, no matter what this is, it forces this cell to be even. So this is 2, 4. This is 2, 4, 6. Okay. But what this can't be a 2 ever, because if this is a 1, it removes the 2. If this is a 2, it still removes the 2. So this is 4, 6. Now this can't have a 1 on it. So this can't have 2. We can't have 2 odds here, which means this can't be the 3. So this is the 1, which means that this is a 4, 6 pair, and that makes this a 3, which means this is a 1, 5 pair. This can't be a 3 anymore. Okay. We have a 4, 6 pair here. So the remaining digits are a 2, 5. This is 2, 3, 5. This doesn't matter what it resolves as. This is done. This is basically done. Okay, so we got to think about these. So we know there's 1 odd on here. So this is even, 2, 4, or 6. But we can't put the 2 because it's consecutive with the 1. Do we need to think about this one, or is there any Sudoku to do, is really the question. 3's in one of these 2, not super helpful. 1 ends up over here. this can't be a 1 because this is 1 or 2, which removes 1 and 2 from the rest of the line, no matter what it ends up being. So that's not a 1. So that is a 1, which makes that a 5 and a 1. Okay, that makes that a 2. We get our 5 and our 2, so that was quite helpful. Can we do more with 1s? Do we have all our 1s? I mean, 1's down here, I guess. And then 1's here. Okay. Okay, so if I wanted 1 even, then this would be, one of these would be, oh, right, this, okay. This can't be 4, 6. And because of this 1, 2, it can't be a 2 either. So this cannot be even. So this is 3, 5 only, because it can't be 1 either. So this is odd. So no matter what, okay, it's similar to this situation. Whether this is 1 or 2, it forces this to be even in order for this to be true. If it's 1, that's odd, so this has to be even to get our 1 even. If it's 2, that's even, but we need 2 even, so this is still even. So this is also a 4, 6. Now, because this is 4, 6, this cannot be a 5. Whether this is 4 or 6, it will remove 5 from the rest of the Ramban, making that a 3, placing that 3 as well. This is 2, 4, 6. And so this is the 5. That gives us 3 and 5 here. We doot for putting 3 in the corner. This is 1, 4, 6. Okay, that's good progress. So this just needs to resolve with Sudoku, I think. I don't think this can resolve any other way. Oh, the 3 actually resolves it. Sorry. We can't have 4 on this line because it's consecutive with 3. So that's a 6. And that places this 6. And that place does not place the 6. This is a 4, 6 pair. This is a 2, 4 pair. 4, 6 pair tells us the order. That's 2, that's 4, that's 6. We get our 4 and our 6 here. All right. This cell is a 2. This column needs a 5. Here we need a 3 and a 4. This 4 tells us the order, 3 and 4. So this is 3, 5. That's 5, 3. And then this is 1 or 2. Okay, so how do we resolve this? Is there a nab? Yeah, the 3 resolves it. I removed the 4, but I didn't remove the 2. So that's a 1, that's a 2, that's 4, that's 2. That's 4, that's 6, that's 1, that's 6, that's 4, and we're done. All right, very neat. Thanks, GDC. I really like the odd lots and even lots. There's some cool logic with them. It's kind of crazy how they kind of can self-contradict sometimes. Like, what was the good example there? Like just being able to place a digit, or rule out like a 2 because it would self-contradict as, yeah, like the 2 here wasn't possible because 2 itself is even. So if we wanted 2 odds on here, this would have to be 2, and that's even, so it doesn't work. All right, anyway, enjoyed this puzzle. Hope you did as well. If you did, then why not leave a like, subscribe, and a kind comment below.